Welcome to this video series on multiple choice chemistry. As always, I'm going to be simplifying chemistry once more for you. So we have 4 questions in this video. So let's run through it together. The first question: which structure is incorrect? Which structure is incorrect? So let's pick the first one. A. Just look at the way the atoms of carbon are bonded in A, B, C, and D. Now, one thing is very key here that you need to solve this question. You must recall the fact that carbon is an atom with atomic number 6, and so looking at the electronic configuration of carbon, you have 2 and 4. So that means carbon needs how many more electrons to form the octet configuration in the outer shell? Yeah, can you suggest? Okay, good. Carbon needs 4 more electrons from other bonding atoms. So carbon, therefore, is said to be tetravalent. Tetravalent. That means has a valency of 4. No, we are not taking into consideration of hybridization and other stuff now. So when carbon gains 4 more electrons, the electronic configuration becomes 2,8, and so it becomes stable. So in organic compounds, for every carbon atom that you see must be surrounded by what? By 4 bonds. This carbon atom is surrounded by 4 bonds. So let's begin to check the options. Any carbon atom that is not surrounded by 4 bonds will not be a correct compound. So if you look at this carbon atom, you have 4 bonds surrounding here, even though you have 3 groups of bond. Here we have 3 groups of bond, but we have 4 bonds ultimately. This is a double bond. We have a double bond, okay, here, and here we have single bond. Here we have single bond here. Okay, that's instructive. Now, looking at this, we have 1, we have 2, we have 3, and we have double bond here. So if you have 3, plus 2, that gives you what? 5. That means we have 5 bonds surrounding this carbon atom, and of course at this carbon atom, and that is absolutely incorrect. Okay, so let's check these two to be absolutely sure. 4 bonds surrounding this carbon atom and 4 bonds surrounding this carbon atom. So which do you think is incorrect? Which structure is incorrect? Is absolutely C. Structure C is incorrect. So the answer to this question is C. Is that taken? Good. Now let's go on to the next question. Which structure shows a compound that belongs to a different homologous series to propane? Talking about homologous series, homologous series, the word homo means similar, the same. They have the same unique property. So homologous series, the family of organic compound having the same general method of preparation, the same general molecular formula, but different. Each atom or successive molecule, rather each successive molecule in the series differ by CH2. Each successive series molecule in the series differ by CH2. Example, if you take the arcane homologous series, the arcane homologous series, okay, the arcane homologous series, they have the general formula C N H 2n plus 2. That's the general formula for that series, Cn H2n plus 2. So the first member of that series is methane. So that will be CH4. The second member is ethane. That is C2H6. So if you look at the difference between the first member, the second member, the third member is propane, C3H8. So if you look at the difference in them, this difference between this is CH2. The difference between methane and ethane is CH2. So these compounds are said to belong to a family called alkane, which is an homologous series. Is that taken? Okay. So we can look at another family of organic compound, another homologous series, which will be let's take alkene as a family. Alkene as a family. Alkene, okay, they have a general formula CnH2n. CnH2n. So the first member of that family is an ethene. You need 2 carbon atoms to start that family, really 2 carbon atoms to start a family. So you have ethene, that is C2H4. The next one will be propene, C3H6. The next one will be butene, C4H8. So if you look at the difference between this and this, 2, 3 is 1 carbon, 4, 6, 2 hydrogen. The same thing goes with this. Between this and this, 1 carbon. Between this and this, you have 2 hydrogen. So these are family compounds in the same family: ethene, propene, butene. They belong to the same homologous series, alkene. They have different molecular formula, but they have the same general molecular formula. That's the difference between specific molecular formula and general molecular formula. So they have the same general molecular formula. So if you look at these, all you need to do is just to slot in 2 carbon. That means N when N is 2. So you have 2C2H, 2 times 2, 4, and that gives you this. The same thing, you can apply it all through. Now back to our question. So let's look at this. For specific homologous series, another thing that I need to say is that each members in a particular series have an identifier, and that identifier is their functional group. Functional group. Functional group. Okay, functional group. The functional group, it's a part of a molecule that determines largely its chemical property. So members of a particular family have the same functional group. Alkane, all alkanes have homologous series, carbon to carbon single bond. All alkanes homologous series have carbon to carbon double bond. Carbon to carbon double bond. That's the homologous series group, rather. That's the functional group. So let's look at this. Which structure shows a compound that belongs to a different homologous series to propane? To propane. Propane. So that's the key word there. Propane is this. Okay. Yeah, that's propane. All you have is just single bond all through. Single bond all through. Single bond. Hydrogen. Hydrogen. Okay. You have hydrogen, hydrogen. Good. That's propane. No double bond. All you have is just single bond all through. So the functional group is carbon to carbon single bond. Now, so the first option, carbon to carbon single bond. Okay, yeah. So it has the same. It shows that it belongs to the same homologous series, the same family alkane. This is methane. This is ethene, has carbon to carbon double bond. This is butane, carbon to carbon single bond all through. Now this is isopentane. Okay, so in fact it looks like isopentane, but this is not a carbon atom. So that's this compound D is absolutely wrong. So it's not even a compound that we can relate with. So the correct option here is B. B is the correct option because it has carbon to carbon double bond, which is not the functional group of the homologous series alkane, which propane belongs to. So let's take the next question. A macromolecule is a very large molecule. Macromolecules can be made by joining smaller molecules together. This is called polymerization. So this information just there to help you. Which role in the table describes the formation of a polymer? So you must be able to recall the meaning of a polymer. What is a polymer? A polymer, it's a large molecule, has that been said, consisting of smaller molecules joined together. These smaller molecules are called monomers. Monomers. Okay? So to answer this question, you must know what monomers are. Monomers are the smaller molecules that make up a polymer via the process of polymerization. Now, for looking at the options, A, if the monomer is ethane, the polymer polyethane, actually ethane don't polymerize. Alkane don't undergo polymerization. Ethene, so this is absolutely wrong. Ethene being monomer and the polymer polyethene. Okay, that sounds right. Okay, ethane, I said earlier, don't polymerize. So we have B and D to consider. Now, when your ethene polymerizes, that's one of the chemical properties of ethene. Ethene undergo polymerization. So you have many ethene molecule coming together, okay, to form, you know, polymer. Ethene polymerize, many ethene molecule coming together. So just to show a simple formula for equation for, you know, polymerization, you have N here, many ethene molecule coming together, and so for this, what happens when polymerization takes place? The double bond will be broken. Okay, the double bond between the carbon atoms will be broken. Okay, so when the double bond breaks, it's like a kind of, you know, addition reaction. Yeah, it's a kind of addition reaction. So you have this. So this is called a polyethene. Is a polyethene. It's simply telling us that you have many ethene molecules combined together. But essentially, a polyethene, a polymer, is actually uh, an alkane, belongs to the alkane, you know, it belongs to the alkane family, alkane homologous series, because all you have there is carbon to carbon single bond. In this case of a polyethene, all the double bonds have been broken up, so the resulting polymer will be an alkane. So the best correct option here is B. B is the correct option there. Poly when many ethene molecules come together, and that is shown by using N to show thousands of molecules of ethene coming together. The resulting polymer will be called a polyethene, and not written together like not polyethene, no, bracket. This bracket tells us that the monomer there is actually ethene molecule. So when your monomers come together, the final name reflects the monomer that is that make up the molecule. Good. So the correct option there is B. Okay, next question, and this will be your final question in this video. Diesel, petrol, and bitumen are all A, fuels, B, hydrocarbons, C, lubricant, and D, waxes. You should be able, to recall the properties and uses of petroleum fractions. Diesel, petrol, bitumen are actually petroleum fractions, but not all are used as fuel. Okay, now let's look at the second option there, that is B. What are hydrocarbons? Hydrocarbons are compounds that contains carbon and hydrogen only. Carbon and hydrogen only. Carbon and hydrogen only. Let me use the symbol. Hydrogen only. Those are hydrocarbons. Okay, now let me give you a quick review of the uses of petroleum fractions. Okay, you can see refinery gas, what is being used for. Okay, for cooking as fuel. Gasoline is being used as fuel in cars. Naphtha, is used in making many chemicals. Kerosene also used as fuel. Diesel oil used as fuel. Fuel oil, lubricating fraction, and bitumen. They are all of these are hydrocarbon. They contain carbon and hydrogen only, except for cases where you have impurities like sulfur, being part of the fuel, the hydrocarbon. Okay, bitumen is an hydrocarbon. Yes, is a hydrocarbon molecule, but it's not being used as fuel. Okay, you could burn, but it's not being used as fuel. Lubricating fraction, not being used, as fuel. They are oil for car engines and machinery, waxes and polishes. They're used for gears and for reducing, frictions. Okay, and of course, bitumen is used for road surfaces and for roofs. So let's go back to our question. So, what do you think the correct option here will be? Diesel, petrol, bitumen. They are all hydrocarbons. Yes, they are all hydrocarbon. All of them are hydrocarbon. They are all hydrocarbon. Diesel is hydrocarbon. Petroleum is hydrocarbon. Bitumen is hydrocarbon. Okay, but they are not all being used as fuel. No, 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 no. They are not being used as lubricants. They are not being used as waxes. So the best option that describe diesel, petrol, and bitumen is hydrocarbon. So the correct answer to that question is hydrocarbon. I sure this video has been very helpful. Join me in my next video series. Thank you.